Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P15B0 refers to a malfunction in the crankshaft position CKP sensor signal, while P15C0 indicates an intermittent interruption of this signal. The CKP sensor plays a crucial role in the engine management system by monitoring the position and speed of the crankshaft, which is vital for accurate engine timing and fuel delivery. It is typically located near the engine's crankshaft, allowing it to detect rotational position effectively. For the Honda Odyssey from 2011 to 2017, if these codes appear, it is indicative of potential issues affecting engine performance, including misfiring or stalling. Diagnosing these codes is critical to ensuring optimal engine function. Thus, understanding the potential causes, symptoms, and troubleshooting steps is essential for vehicle repair and maintenance. The Crankshaft Position CKP sensor is responsible for monitoring the crankshaft position and speed. This information is essential for the Engine Control Unit (ECU) to manage ignition timing and fuel injection accurately. In the Honda Odyssey, the CKP sensor is situated near the crankshaft, making it accessible for both monitoring and servicing. Any issues with this sensor can lead to performance-related problems, including rough idling, power loss, and difficulty starting the engine. When DTC P15B0 or P15CO is triggered, it indicates malfunctions in the sensor's signal transmission. Therefore, understanding the function and location of the CKP sensor is key to troubleshooting and resolving the error codes effectively. The possible causes for DTC P15B0 and P15C0 can include poor electrical connections, which may disrupt the signal between the CKP sensor and the engine control unit. Loose terminals at the CKP sensor or connection points can also lead to intermittent or failed signals, potentially causing engine performance issues. Furthermore, a malfunctioning CKP sensor itself can produce incorrect signals or fail altogether, resulting in these diagnostic trouble codes. It is crucial to methodically examine each of these potential causes during troubleshooting to determine the root of the problem. Before proceeding with repairs, all freeze data should be carefully recorded, as any stored data can assist in diagnosing the specific cause of the DTCs. While the specific symptoms can vary, common experiences when DTC P15B0 or P15C0 is triggered include engine stalling and rough idling. These symptoms arise due to incorrect timing for fuel injection or ignition as a result of erroneous signals from the CKP sensor. Additionally, drivers may experience difficulty starting the engine. The vehicle may hesitate or not start at all. Abnormal engine behavior can pose risks while driving, leading to a decreased overall vehicle performance. Recognizing these symptoms early is essential for effective troubleshooting and prompt repairs. Doing so can prevent further complications from developing. In troubleshooting DTC P15B0 is to turn the ignition switch to the on second position. This prepares the vehicle's systems for diagnostics. Next, utilize the Honda Diagnostic System, HDS, to clear the DTCs that are currently stored in the vehicle's computer. This allows any existing error codes to be reset before proceeding. After clearing, start the engine and allow it to idle for 20 seconds. It's necessary conditions for the engine to stabilize. This initial step ensures that any transient errors do not interfere with further diagnostic testing. Once complete, checking for any pending or confirmed DTCs with the HDS is crucial to determine if the problem persists. After idling the engine for the required time, the next step is to check for any pending or confirmed DTCs using the Honda Diagnostic System HDS. It is essential to identify whether DTC P15B0 or P15C0 is indicated again during this check. If the system shows either trouble code, it signifies that there is still an issue requiring further investigation. However, if neither code is present, it might suggest an intermittent failure, and the system may be functioning adequately at that moment. In this case, it is advisable to check for poor connections or loose terminals at both the engine mount control unit and the powertrain control module, PCM. This approach helps identify any transient faults that may not consistently trigger the codes. Turning the ignition switch to the lock position is the next step before proceeding to inspect electrical connections. Begin by carefully checking for poor connections or loose terminals at the engine mount control unit 16P connector. This component is crucial as it links the CKP sensor to the engine management systems. Additionally, the PCM connector, A49P, must also be inspected as faulty or loose connections here can impact the sensor's signals significantly. Ensuring that both connectors are secure and in good condition is vital for proper operation. If connections appear compromised, repairs should be made as they can often resolve the engine signal issues indicated by DTC P15B0 and P15C0. Proper diagnostics here can lead to successful resolution. In this step, the CKP sensor 3P connector must be disconnected to perform a voltage check. Once the connector is detached, the ignition switch should again be turned to the on/to position. Using a multimeter, measure the voltage between terminal number 12 of the engine mount control unit 16P connector and body ground. It is essential to get a voltage reading of approximately 5 volts. This measurement is crucial as it indicates whether the engine control unit is supplying the correct voltage to the sensor. If the reading is as expected, the next steps will involve additional diagnostics. If not, further investigation into the wiring or the control unit's functionality will be needed. Establishing proper voltage at this stage is critical for moving forward in the troubleshooting process. This step involves turning the ignition switch back to the lock, 0 position to safely work on the wiring. Then, connect CKP sensor 3P connector terminal number 3 to body ground using a jumper wire. This essentially creates a direct link for measuring the circuit's integrity. After making this connection, it's necessary to assess whether the CKP sensor is functioning properly by monitoring how it perceives the ground reference. A consistent reading while the circuit is grounded indicates that the sensor and wiring are likely functioning as intended. If the expected results are not achieved, this could point to a defective CKP sensor that may need replacement to rectify the issues correlated with DTC P15B0 or P15C0. After all the necessary repairs have been completed on the CKP sensor and its connections, it is essential to conduct a final verification process. This involves taking the vehicle for a test drive to allow the engine control systems to operate under normal driving conditions. During this drive, monitor for any reappearance of the DTCs P15B0 or P15C0. If neither code is triggered during this period, it indicates that the repairs were successful and that normal operation has been restored. Verifying the repairs is a critical step to ensure the reliability of the fix and to rule out any further complications. If the issue persists, further diagnostic procedures may be warranted to ensure comprehensive vehicle performance. To prevent future occurrences of DTC P15B0 or P15C0, it is essential to implement preventive maintenance strategies. Regularly inspecting the electrical connections related to the CKP sensor can help identify potential issues before they become significant problems. Keeping wiring harnesses secure and free from fraying or damage is another important aspect of maintenance. Additionally, scheduling routine diagnostic checks, if the vehicle exhibits any unusual behavior, can provide early detection of issues. By establishing these practices, vehicle performance can be optimized, and the risk of signal malfunctions can be significantly reduced. Comprehensive maintenance serves as an essential means of preserving engine health over the lifespan of your Honda Odyssey. In summary, understanding the role of the crankshaft position CKP sensor is vital when dealing with DTC P15B0 and P15C0. Following the outlined diagnostic steps can bring clarity to the issues affecting the vehicle's performance. As the CKP sensor is crucial for engine timing and the overall operation of the vehicle, addressing any faults promptly is essential. Performing preventive maintenance practices can help safeguard against future issues, ensuring a smoother driving experience. Remember, the key to successful vehicle repair lies not only in fixing current problems, but also in being proactive to prevent future breakdowns and ensure long-term reliability. Please like and subscribe to the channel. See you next time.